So now we are going to see that how much number of the atoms will be present in a unit cell within a given crystal. You will understand. So we are going to calculate the number of atoms present in a unit cell. Of course, we are knowing the three important types of classification: in a primitive, body-centered and a face-centered. So in these three unit cell, what would be the number of the atoms present in a unit cell? Please mark my words, in a unit cell. So before going to that part, I have to just make you aware of a certain mathematical part. For example, you are having a cake. Okay, one full cake is there. Okay. So if this cake has to be distributed among the 8 members, so one full cake has to be distributed among 8 members. My question is that how much piece of cake does one member gets? Okay, so one full cake is equally distributed among the 8 members. ಆದರೆ ಇಡೀ ಒಂದು ಕೇಕ್ ನ 8 ಜನ ಮಧ್ಯದಲ್ಲಿ ಹಂಚ್ತಾ ಇದ್ದೀರಾ ಅಂದಾಗ ಒಂದು ಜನಕ್ಕೆ ಅಥವಾ one child, what would be the quantity of this cake he would be obtaining? Of course, it will be 1/8. You will understand. So this is the topic you have to remember now when we are doing the calculation for the number of the atoms in a primitive unit cell, in a body-centered unit cell and a face-centered unit cell. Very much important. Once again, I am repeating, if you are having the one full cake and you have to distribute among 8 members, then each member will be getting 1/8 of this one full cake. That is the concept. The same concept is utilized. Instead of cake, we are going to use here the atoms. So first important thing, let us go with that of your number of atoms. Okay, in the first case, in primitive unit cell. What we know in this primitive unit cell, how does your atoms are arranged? We know that in a primitive unit cell, the atoms are arranged only at the 8 corners of the unit cell. 8 corners of unit cell. That means what? Remember, in a given crystal, if this is your crystal, if I am choosing this one as my one unit cell, and here is our one atom present. Okay, this is our atom. Let me take this one as my atom. Okay, in one corner. Of course, there are 8 corners. In one corner, I am choosing. That means what? This one atom is equally shared from this unit cell, first unit cell, of course, with respect to that unit cell, and also the unit cell which is backside of it. Okay, you can just see that this is the line of the second unit cell. Even this atom is also shared with respect to this unit cell. Also, this atom is shared with respect to this unit cell. But it doesn't stop over there. Even it has been shared by this unit cell. One more, this part, backside of it, 6th one. And also this atom has been shared with this unit cell and also with this unit cell. So totally there are 8 unit cells which is contributing or which is taking part in its attachment of the corner atom. That means what? If I consider this one as instead of a cake as an atom, one atom has been shared with respect to the 8 unit cell. So that means what happens when we are considering, we know that in a primitive unit cell there are such 8 corners. Okay, if one corner is being bonded with respect to 8 unit cells, then such 8 corners will be bonded with how many unit cells? 8 into 1/8. So that will be giving you the number of atoms as 1 atom. So in a primitive unit cell, the total number of the atoms, that is as a whole, I am considering as a one whole atom. Such one whole atom is present in a primitive unit cell. You can ask me, sir, there are 8 Allah. Of course there were 8. But what is happening when this is a half, it will be a from here half, from here half, from here half. Such a half constitutes how much? Just one atom. So one whole atom is present in that of your primitive unit cell, because the atoms which are present at the corners of the unit cell is in turn attached to that of the 8 other unit cell. So for one unit cell, what will be the number of atom? 8 into 1 by 8, which will be equal to totally 1 atom is present in primitive unit cell. Is that clear? Now the second part we have to see with respect to that of your body centered. Body centered. Remember, in body centered, if I am going to write it, I am going to write in this way. Alva. That is, you are having the atoms at the corners. You are having the atoms at the corners and also at the center of the body, like this. So we know that in a unit cell, if the atoms are at the corners, it constitutes how many atoms? 8 into 1 by 8, that is equals to 1 atom, because the corner atoms are in turn attached to the 8 other unit cells. From here, from here, from here, 8 other unit cells they are attached of. That is the reason we are having one whole atom is obtained in a only the atoms which are present at the corners. Remember, the body centered, this atom is not attached to any other unit cell. This atom solely or individually belongs to the one unit cell itself. So as a whole, it will be remaining in this unit cell itself. So body centered constitutes how much atoms? 1. So that will be resulting in one more atom. So in a body centered, you will be having totally 2 atoms. Is that clear? So in body centered, the atoms which were at the corners were equally attached to other 8 unit cell, resulting in 8 into 1 by 8. Overall, it was giving us 1 atom. Whereas the atom which was present at the body centered, it is not attached to any of the other unit cell within a lattice, crystal lattice. And that is the reason what happens? It will be individually belonging to that particular unit cell itself. So in a body centered unit cell, you will be having totally 2 atoms. Coming with respect to that of your face centered unit cell. Face centered unit cell. We know that in the face centered unit cell, we are having at the corners and also at the 6 faces of the each cube. For example, if I am going to write my cube in this way. Okay, this is one unit cell. Okay, and there is another unit cell here like this. Like this. Okay, so we know what, of course, in this unit cell the atoms are present at the corners, 8 corners, of course, alva. So like this. And also at the 6 faces. Let me just consider here one face. Okay, one face. Able to see that the face atoms is only attached to one more unit cell. That is, this atom is attached to this unit cell and also to this unit cell. Similarly, if I consider over here one more unit cell at the top. If I consider over here back side, means one more unit cell over here. So here one more unit cell, here one more unit cell, and over here one more unit cell. That means what? Each phase atoms is in turn attached to this unit cell and this unit cell. That is 1 by 2. So 8 corners atoms, we know that it is attached to 8 other unit cell, giving you as equals to 1 full atom. Whereas the atoms which are present at the 6 faces, we know that there are totally 6 phases, and each phase atom is attached to how many unit cells? 2 unit cells. So it contributes to how many portions? To 1 by 2. So we will be getting as total atom as the full atom in a phase center, you are getting as 3 atoms, considering all the 6 phases. So total number of the atoms present in a phase center unit cell is 4 atoms. Is that clear? Let us go on once again. So in a primitive unit cell, we came to know that if I am considering any one corner atom, we could choose that this atom belongs to the first unit cell. This atom also belongs to the second unit cell, third and the fourth, fifth and the sixth, seventh and the eighth. So totally one atom which is present at the corner is equally shared among the 8 other units. So if I consider one particular unit cell, there will be such 8 corners. So it will be resulting in how much portion? 8 into 1 by 8. That will be giving you overall one atom and present in a primitive unit cell. Coming with respect to the term of your body centered, of course the 8, as we have done with primitive, 8 corners is individually attached to 8 other unit cells, giving you one atom. But on body center, we are also having an atom at the body center. This part is not attached to any other unit cell and individually belongs to this unit cell itself. So one atom remains overall as one atom as such, giving you the total number of atoms as 2. Whereas in a face-centered unit cell, what happens? Of course, the 8 corners is going with respect to that of your 8 unit cell, giving you the one whole atom. But there are 6 phases, and each phase atom is in turn being attached to that of the 2 unit cells. So that means each phase is given to 1 by 2 part. That is, how many phases are there totally? 6 phases. So 6 into 1 by 2, giving you how much? 3 atoms. So overall atoms present in a face-centered unit cell is 4 atoms. So by this way, we are saying that what would be the number of the atoms in a primitive unit cell? That is equals to 1 whole atom. In body centered, 2 whole atoms, and in a face centered, 4 whole atoms are present. So in our next class, we are going to see that how these atoms are arranged in a 3-dimensional array. Very much important. Remember, 1, 2 and 4, they are the whole atoms present in it.